Hello students, today we will be going to take a topic from class 10th, that is the chapter polynomial. In the previous lecture we have taken the graphical presentation and we have seen the relationship between the exponent of a variable with the number of zeros. So today in this particular lecture we will be going to take the relationship between the zeros and the coefficient of the polynomial. So to start with, I am taking a linear polynomial. Let there be a linear polynomial given as ax plus b. And if I say that, as we have studied in class 9, if alpha be a zero of this polynomial, then this particular polynomial at alpha will be 0. So that is the main part of that. So according to this we can write x minus alpha is a factor. And that also we can check it, as the polynomial is given to you. This implies it becomes a into alpha plus b is equal to 0. So a alpha will be equal to minus of b. Alpha becomes minus b upon a. So the relationship here we can write, it is minus coefficient of, the first part is b. B means it is the constant term, upon a is the coefficient of x. So this is the relationship. That is, we are having the arbitrary constants a and b here, and alpha be the 0, then the 0 can be obtained as minus b upon a. Now if I relate these two things, that is, if alpha is a 0 of this particular polynomial, then this becomes the factor of the polynomial px. So we can compare this one also. So we can write, after we are getting a factor, since it is a linear one, px can be written as k times x minus alpha. So this becomes kx minus k alpha. It is already given that px is ax plus b. Now if you compare the terms, after comparing, both the polynomials are same, so we will get k is equal to a. That is, x is having coefficient k, here x is having coefficient a, so k must be equal to a, and minus of k alpha should be equal to b. So we will be going to get alpha to be equal to b upon, this minus will go to that side. I will be writing like this first, minus of b, alpha becomes minus b upon k, and k, as we know, it is equal to a only. So the same thing we are getting from this side also. So that was according to class 9th, where if alpha is a 0 of the polynomial, then x minus alpha is a factor. That is a factor theorem of class 9th. So now, in the same way, if you go for a quadratic polynomial, so that is the relationship here, and that is the formation of a linear polynomial. Now if we take a quadratic polynomial, let p is equal to ax square plus bx plus c. Now this is a quadratic polynomial where a, b, c, the same thing, are arbitrary constants, and if you see, a is with x square, so it is the coefficient of x square, b is a coefficient of x, and c is the constant term. Now if I say that after this, if alpha and beta, as we know for quadratic, in the previous lecture we have studied that the quadratic polynomial will be going to have maximum 2, इसके 2 से ज़्यादा 0 नहीं हो सकते. Let those two zeros be alpha and beta. Now if I say that alpha and beta are two zeros of this polynomial px, so what you will say here, that p alpha and p beta both should be equal to 0. If both are equal to 0, then we can say x minus alpha and x minus beta are the factors of px. Now this implies px can be written as Px can be written as, it is x minus alpha and x minus beta. Since there are two factors, I am putting this k. So we will be going to get k if you multiply by distributive property, distribution, that is when we are multiplying these two things, we will be going to get x into whole x square minus alpha x minus beta x plus alpha beta. Now if you multiply, this becomes kx square. It is k times alpha plus beta is common here, and this is k alpha beta. And we know that both the polynomials are same. We have said that for this particular polynomial, these two are the zeros and the polynomial is already given. So on comparing, so what we can compare? This polynomial is already given to you as ax square plus bx plus c must be equal to kx square minus k alpha plus beta x and k alpha beta. So we can compare the first term. If you compare the first term, we are getting k is a. The second part, if you compare x, we are having minus k times alpha plus beta, which is along with x. And here along with x we have b, must be equal to b. So alpha plus beta will be equal to b upon minus of k, that is a. So I am putting this minus sign first here, taking k to that side. So we are getting alpha plus beta is minus b upon a. And if we compare the third part, so this is the first part that we have compared, this is the second term that we have compared, and if we compare the third one, we will be going to get, third one means here the constant is c, there it is given k alpha beta, which is equal to c. So alpha beta is c upon a. So this is the relationship that we were searching for. You can see that alpha plus beta, that is the sum of the zeros, and alpha into beta, that is the product of the zeros, can be written as minus b upon a and c upon a respectively. So this was the relationship between the coefficient. So I am just summarizing this one, you can copy it down. Okay, now what we can do here, we will write the conclusion of that part that we have already taken here. So if we say for quadratic, if we say for a linear, when it is given as ax plus b, alpha will be minus b upon a, that is equal to minus constant upon coefficient of x. And if we take a quadratic, here we can write where alpha is a 0 of px. Now if we have a quadratic bx plus c, then alpha plus beta, as we have deducted, minus b upon a, and alpha into beta is c upon a. So that is the relationship. So we can write this one as minus coefficient of x upon coefficient of x square. This is constant upon coefficient of x square. So this was the relationship that we were searching for, and along with this also we have deducted one more part, that is the formation. Formation of linear polynomial will be px, that is equal to k x minus alpha. If the zeros are given for quadratic, px will be equal to k x minus alpha and x minus beta. If you know, otherwise we can write k into x square minus alpha plus beta into x plus alpha beta. So this one we can write k x square minus, I'll write s and I'll write p, that is where s is sum of the zeros and p stands for product of zeros. So this was all about the topic that we were planning to take in this particular exercise, this particular lecture. So that is the relationship between the coefficient of the zeros and the coefficient of the polynomial. So that's all.